If someone told you that taking a certain nutrient or drug could kill some of your cells, you might think it was a bad idea. What few people understand is that as cells age, some of them degenerate into a population of poorly functioning senescent cells that accumulate throughout the body. There's no value to retaining these lingering senile cells. Their continued presence underlies a myriad of degenerative disorders. Senescent cells should be purged from the body. The buildup of these dysfunctional senile cells contributes to decay of individual organs and greater susceptibility to disorders related to chronic inflammation. Pharmaceutical companies are developing technologies to remove or neutralize senile cells. They view this as a lucrative target of anti-aging research. The objective is to selectively remove senescent cells without damaging healthy cells. Rather than wait for expensive drugs, scientists have discovered that the plant flavonoid quercetin has the unique ability to selectively remove old cells without harm to normal, actively dividing cells. This has the obvious potential for extending health span. A number of studies suggest that low-cost quercetin may slow aging and reduce the risk of many age-accelerating processes, both by clearing senescent cells and via other beneficial mechanisms. Quercetin combats aging at the cellular level. Scientists have identified a group of pro-inflammatory aging cells, or senescent cells, in various tissues and organs. Certain kinds of these cells actively secrete substances that generate inflammation and accelerate aging of organs, which results in aging of the entire body and susceptibility to chronic, age-related disorders. Quercetin, a naturally occurring nutrient, was recently shown to selectively delete dangerous senescent cells in laboratory studies without harm to healthy, youthful cells. This finding may help to explain quercetin's known age-decelerating properties, which have contributed to reduction in diseases from the brain to the heart and lungs to the intestinal tract and even bones. A true life-extending supplement regimen should include regular quercetin doses of 150 to over 500 milligrams per day. A dose of 150 milligrams may be sufficient for most people. One strategy might involve taking the higher dose range of quercetin, which is over 500 milligrams per day, for several months, and then dropping back to a maintenance dose of 150 milligrams each day. It might seem logical that our cells age at the same time as our body as a whole, but that is not the case. Cells have varying lifespans. Some cells live only briefly and replace themselves frequently, while others have longer lifespans and are replaced only after weeks, months, or even years. The exact frequency of cell renewal depends on the tissue in which the cells are found. In the presence of various detrimental stimuli such as ultraviolet radiation, oxidation, and environmental toxins, some cells undergo changes to their DNA that results in old cells that won't die when they're supposed to. Scientists refer to these as senescent or senile cells. Senescent cells pose a significant health problem because many of them produce pro-inflammatory signaling molecules and protein-digesting enzymes that contribute to acceleration of age-related diseases. A healthy immune system can help remove senescent cells as part of its normal cellular housekeeping. This process is important in cancer prevention. As bodies age, the immune system itself begins to age via a process known as immune senescence. As a result, removal of senescent cells begins to fail. This leads to an acceleration of aging, and ultimately an increase in the risk of most age-associated conditions, including cancer. By selectively eliminating senescent cells so that they do not clog up our body's processes, it is possible to support or even regain youthful function in every organ and tissue. This was shown in a compelling fashion in a 2011 study from the Mayo Clinic using a mouse model of rapidly accelerated aging similar to the disease progeria in humans. Progeria is a rare disease of accelerated aging. It is the result of a gene mutation that produces premature accumulation of senescent cells and causes young children to age so rapidly that most die before age 15, commonly of atherosclerosis or other age-related processes. The Mayo researchers transplanted into the rapidly aging mouse model a specialized gene that selectively eliminated senescent cells. They found that by removing senescent cells in tissues such as fat, skeletal muscles, and the eye, they could significantly delay onset of age-related disorders in those tissues. These included muscle loss, cataracts, and depletion of subcutaneous or under-the-skin fat. Perhaps still more exciting, clearance of senescent cells even in late life slowed the progression of age-related disorders already in progress. This study opened the door to the idea of senolytic or age-busting drugs. Testing this kind of gene transplantation therapy in humans is fraught with risks. A better, safer, and simpler solution was discovered in early 2015 by another group of scientists from several institutions, including the Mayo Clinic. The second Mayo study was carried out by researchers who recognized the threat of senescent cell accumulation. These scientists sought to correct this pathology in a simpler and safer way than gene transfers. They knew from past research that clearing away just 30% of senescent cells produced profound improvement in age-related signs and symptoms. The researchers turned to several compounds known to induce cellular suicide, known technically as apoptosis, preferentially in senescent cells, while leaving healthy cells untouched. They tested 46 different drugs and nutrients and ended up with two candidates, a chemotherapy drug called dasatinib and quercetin, a well-studied nutrient found naturally in apples, onions, and other vegetables. Both compounds powerfully affect the cellular regulation systems that produce beneficial apoptosis, but dasatinib, unlike quercetin, has a wide range of serious toxic side effects. When human cell cultures were treated with either quercetin or dasatinib, the researchers found a sharp reduction in numbers of senescent cells. In this study, quercetin caused about a 50% reduction at the lowest two doses, with no effect on healthy cells. Dasatinib had similar effects when used alone. In an animal study, the combination of the two compounds was still more effective. When administered to age-accelerated mice, the combination caused a significant reduction in a score of age-related symptoms, including hunched back, poor muscle function, tremors, loss of grip strength, gait abnormalities, urinary incontinence, and poor body condition. These effects were interpreted as an extension of the health span of the mice, both because of the delay in symptom onset and the reduction of their severity. Of course, no one is proposing that dasatinib, a powerful chemotherapy drug, be used to prevent human aging. This study shows that quercetin alone is just as effective at deleting dangerous senescent cells as the drug dasatinib, and that such deletion delays aging and promotes a longer health span. Like most natural supplements, quercetin appears to achieve its effects by multiple pathways. For example, quercetin activates a well-researched enzyme known as SIRT1 or SIRT1, which is also activated by resveratrol. Recent studies show that activated SIRT1 can suppress the pro-inflammatory signaling of senescent cells, thereby reducing their toxicity and potentially slowing aging. Numerous experiments have demonstrated that animals with experimentally increased SIRT1 activation live longer and experience fewer age-related disorders. Previous animal studies have shown that quercetin can extend lifespan. In one often used model of aging using the roundworm Caenorhabditis elegans, quercetin treatment has been shown to prolong the mean lifespan by 16 to 23%. A wealth of evidence shows that quercetin acts by several mechanisms to delay aging, is safe, and is absorbed from the gastrointestinal tract after an oral dose. It is reasonable to examine quercetin's effects as an age decelerator in the human tissues most affected by aging, as we'll now see. First, quercetin slows cardiovascular aging. Cardiovascular disease, heart attacks, congestive heart failure, and stroke, is the leading cause of death among older Americans. Finding a way to slow aging of the heart and blood vessels is a vital factor when seeking to significantly prolong human life. Quercetin has numerous properties that help to combat various factors involved in heart disease. First, quercetin has the ability to relax blood vessels, an action that reduces the risk of heart attack and stroke. Scientists believe this is due in part to quercetin's ability to fight oxidation. Oxidation in cells that line blood vessels reduces their ability to produce and respond to nitric oxide, a vital signaling molecule that helps control blood pressure by telling cells to dilate and relax. Secondly, quercetin has been found to increase levels of an important enzyme called paraoxinase 2, or PON2. Scientists now believe that this potent enzyme protects fat molecules from dangerous oxidation that can lead to atherosclerotic plaque formation and decreased blood flow. Indeed, animal studies demonstrate that supplementation with quercetin reduces markers of oxidation while increasing heart rate, which is an indicator of good function in healthy animals, potentially improving the animal's long-term health. The third way quercetin helps protect against heart disease is by counteracting the pro-clotting effect of platelets, a leading contributor to arterial blockage in the presence of plaque. In a study of healthy human volunteers, doses of a quercetin supplement at both 150 and 300 milligrams were shown to decrease the clotting of platelets. This action has the potential to reduce the risk of stroke and heart attacks. Finally, quercetin directly opposes major components of metabolic syndrome, the combination of obesity, hypertension, glucose intolerance, insulin resistance, and lipid disturbances, a condition that vastly increases cardiovascular risk. When a group of overweight or obese subjects with features of metabolic syndrome received a daily 150 milligram dose of quercetin for 6 weeks, mean fasting quercetin blood levels were boosted by nearly 4-fold. In this study, quercetin lowered systolic, or top number, blood pressure and reduced levels of oxidized LDL, or bad cholesterol, a contributor to atherosclerosis. Another study evaluated healthy men who had a genetic variant that increases cardiovascular risk. A quercetin dose of 150 milligrams per day was used. After 8 weeks, there were reductions in waist circumference, after-meal systolic blood pressure, and triglyceride levels. Beneficial increases in HDL, or good cholesterol, were found in these men taking just 150 milligrams per day of quercetin. The next way that quercetin affects aging is that it protects brain cells. Scientists have determined that senescent, inflammation-generating cells accumulate in the brain during normal aging. This discovery has opened a new door to therapies aimed at preventing the decline associated with neurodegenerative diseases like Parkinson's and Alzheimer's. With quercetin's ability to selectively delete senile cells in the brain, we can expect further advances in preventive neurology from this impressive natural flavonoid. A great deal has already been discovered about quercetin's ability to reduce the memory deficits and other features of neurodegenerative disorders by protecting brain cell structure and function. Studies show, for instance, that quercetin is absorbed in the blood after oral dosing and is detectable soon thereafter in brain tissue. As a result, quercetin has been shown to help protect the brains of rats subjected to a high-stress environment. In a study published in Free Radical Biology and Medicine, the rats initially developed oxidative stress in vital memory and movement centers of their brains as a result of the high-stress environment. However, when those same rats were supplemented with quercetin, the cognitive deficits they had experienced were reduced. Oxidative stress and senescent cells are significant contributors to the gradual development of Alzheimer's and Parkinson's diseases, two common neurodegenerative consequences of aging. Quercetin has been shown to help battle both of these underlying issues. In a rat model of Parkinson's disease, quercetin or fish oil demonstrated valuable brain protective properties. However, the combination of quercetin and fish oil produced even more protective benefits, such as reducing behavioral impairment, improving production of the neurotransmitter dopamine, and rescuing ailing mitochondria. Also, quercetin protects against environmental toxins. Environmental toxins play a significant role in the development of neurodegenerative diseases. Parkinson's disease, for example, is known to be promoted by exposure to PCBs, a class of environmental chemical toxins. PCBs damage brain cells that produce the neurotransmitter dopamine, which is deficient in Parkinson's disease. Brain dopamine levels steadily decline as humans age past 45 years. One study demonstrated that quercetin reduces damage to dopamine-producing brain cells after rats are exposed to PCBs. Subsequent experiments demonstrated that quercetin protected the dopamine-producing cells by scavenging the destructive oxygen-free radicals induced by the toxin. In addition to memory loss, animals exposed to PCB also developed signs of anxiety. A separate study found that quercetin supplementation was able to reverse both the brain changes and the neurological deficits associated with PCB-induced anxiety. Further supporting quercetin's ability to protect the brain from damaging toxins, a study published in Toxicology and Industrial Health found that supplementation with the nutrient reversed changes in the brains of rats previously exposed to a common industrial solvent called toluene. When the researchers examined microscopic evidence of the animals' brains, they found that quercetin supplementation in fact led to structural improvements in brain architecture that had been damaged by the chemical. Amazingly, these improvements occurred even when quercetin was administered after the brain damage was already done. Exposure to PCB weakens the blood-brain barrier, which allows PCB and other damaging toxins to leak into brain cells. However, researchers found that quercetin can protect brain cells against environmental toxins by stopping them from ever reaching the brain in the first place. Quercetin also helps suppress herpes in the brain. Infection with herpes simplex virus 1 is widespread and typically manifests outwardly as cold sore outbreaks on the mouth and/or lips. What many people don't know is that in approximately 70% of the population over 50 years old, the virus enters the brain and infects neurons. It is not known how many recurrent HSV1 reactivation episodes occur in neurons before infection or herpes simplex encephalitis develops. A fascinating study published in 2015 reveals how quercetin or resveratrol may reduce viral propagation and/or counteract the effects of neuronal herpes infection. The scientists analyzed viral replication, neuronal viability, and neurodegenerative events during HSV1 infection. In this study, pre-treatment of neurons with resveratrol or quercetin significantly reduced markers of damage associated with HSV1 infection. The scientists concluded that their results could be potentially useful in reducing the risk of HSV1 infection in neurons and the cellular damage associated with reactivation episodes. The age-accelerating effects from chronic infections with herpes viruses, such as cytomegalovirus, CMV, herpes simplex 1 and 2, herpes zoster, and Epstein-Barr are increasingly being recognized, especially as it relates to disease. Chronic viral infection creates a sustained inflammatory response that is thought to contribute to increased cognitive impairment seen in preclinical and clinical Alzheimer's disease. It is not yet possible to completely eradicate these chronic viruses, but this new study indicates that resveratrol or quercetin may at least mitigate their pathological impact. Next, let's look at how quercetin enhances the efficacy of resveratrol. Resveratrol has become a popular anti-aging supplement because of its beneficial effect on gene expression. Quercetin has been shown to make more resveratrol available to the body. It does this by reducing the rate of resveratrol degradation or sulfation in the liver and enhancing its bioavailability. When resveratrol is ingested, about 70% of it is absorbed from the intestine into the blood. The absorbed resveratrol is then transported to the liver. When the liver adds sulfate groups, there is some deactivation of the resveratrol. Since quercetin has favorable influences on the bioavailability of resveratrol, it makes sense to take these two nutrients together. Interestingly, while red wine is known to contain small amounts of resveratrol, it usually contains even more quercetin, meaning the health benefits associated with red wine may be due to both its resveratrol and quercetin content, along with other polyphenols. Next, let's look at how senescent cells impact the entire body. Troublesome senescent cells can be found throughout the body. Wherever those cells build up, they cause damage to that part of the body. These retired cells are responsible for increasing malfunctions in a once vibrant body. For example, in the immune system, senescent T cells have been found built up in the lymph nodes of older animals. These older cells are rich in memories of older threats, but are unable to learn about new threats, making them less effective, for example, against next year's flu virus. Senescent cells also affect skin integrity. The impaired skin and wound healing, so commonly associated with aging, may be related to an accumulation of senescent fibroblasts, which are all-purpose cells in the skin that are essential for producing new skin tissue. The most common form of arthritis, osteoarthritis, is due in part to the accumulation of old cartilage-producing cells or chondrocytes in the joints. Joint stresses, such as overuse, produce chronic oxidative stress, which has been shown to hasten chondrocyte aging and accumulation of senescent cells. Senescent cells are also being explored as important targets for treating age-related brain disorders such as Alzheimer's and Parkinson's diseases. Brains of older animals have been shown to contain senescent cells that secrete highly inflammatory cytokines and may contribute to growth of the age-associated brain tumor called glioma. Heart tissue from people with cardiovascular disease contains more senescent, rapidly aging cells than tissue from healthier or younger people. Interestingly, studies also show that, at least in heart tissue, some people may be born with the tendency for their cells to age more rapidly. In theory, this could explain why some people appear to be at higher risk for cardiovascular disease and death than others, despite having similar backgrounds in other ways. Smoking and air pollution promote chronic obstructive pulmonary disease, or COPD. Senescent cells secrete highly inflammatory substances and have recently been discovered in the lungs of smokers with chronic obstructive pulmonary disease and are thought to promote the condition. Finally, senescent cells accumulating in liver tissue hasten loss of liver function. In addition, because these cells progress to form scar tissue, they may be involved in the advance of life-threatening liver cirrhosis from milder, earlier conditions such as non-alcoholic fatty liver disease, or NAFLD. Clearly, senescent cells contribute to aging and disease in organs and tissues throughout the entire body. Fortunately, scientists have discovered a nutrient that selectively eliminates many such senescent cells. By doing so, it may be possible to support or even regain youthful function in every organ and tissue in the body. Quercetin is a low-cost dietary supplement that has health-promoting properties in the heart, brain, and other systems. Doses of 150 milligrams per day have demonstrated significant benefits in human studies and might be a good maintenance dose. Furthermore, higher dose amounts of 500 milligrams to 1,000 milligrams per day are generally recognized as safe based upon current data, especially over the short term, and thus higher dosing in this range may be considered based upon individual health needs. At the current time, little safety evidence exists to confidently support chronic daily dosing higher than 1,000 milligrams. A prudent course to follow might be to take 500 to 800 milligrams per day of quercetin for 3 months to purge accumulated senile cells, and then stay with a maintenance dose of 150 milligrams each day thereafter. You've been listening to an audio version of an article called Sweep Away Senile Cells, published by the Life Extension Foundation in their magazine in 2015. And this video was brought to you by ScottHealthSystems.com. If you like the information you just heard, please support us by purchasing our advanced quality health products at scotthealthsystems.com. We're not asking for donations or charity, but you can support us by purchasing our great products. Thanks for listening, and please support us by not only subscribing to this channel, but clicking on the link below and going to scotthealthsystems.com.